Sorry for technical problems. As I said, I changed my presentation a little bit. So today I'm gonna speak about small introduction to progressive web apps. But before, I will introduce myself. I am Filip. Normally I work in Divante here in Poland, in Wrocław. I'm also a co-founder of Vue Storefront. How many of you heard about Vue Storefront? Okay, so quite many, but it's a headless e-commerce like PWA Studio, DET, Front Commerce, but in Vue.js, so you should check it. Before I will start the presentation, I have two questions to you. First one is, who knows what progressive web apps are? Please keep your hands raised. Okay, and how many of you build progressive web app? Okay, 3, 4. Okay, and so now, how many of you think PWA is a buzzword? Okay, not that much. Basically, during this presentation, I will try to convince you that it's not a buzzword, and it deserves all that buzz that is around this technology. I will make a very brief introduction into what you can achieve with progressive web apps. Basically, we will just see some examples of what is achievable. So let me tell you about progressive web apps, but to be sure that we are all in the same page and we all think about PWA in the same way, let's start with the definition. This is the definition I found in Mozilla Developer Network that is probably the best one to describe progressive web apps. It may sound a little bit confusing, but basically it means that we are trying to deliver the user experience that was previously available only on native applications in the web. And for this purpose, we are using a modern JavaScript APIs with progressive enhancement strategy, which means that we are delivering the baseline of functionality of our application to everyone, like IE 10, IE 11, something like this. But we are progressively enhancing this user experience with modern web APIs. So if users have a browser that supports these features, then they can benefit. But we are not relying on these modern web APIs. So everyone can still use our application. So probably the most important part of this definition is don't rely on modern APIs and always have a fallback. And progressive web apps have like 3 characteristics. First of all, they are fast. They're really, really fast, and this is one of the main goals. The second one, they are reliable, which means you can rely on your application under every circumstances. For example, lack of connectivity, some problems with backend, some problems with support, progressive enhancement, and they are engaging. How they are engaging, we will see in the next slide, but basically it means that we can re-engage users when they leave our web application, which wasn't possible before, because the life cycle of our application is not ending in the browser. How we are achieving all of these great goals? Basically, most of these goals is achieved by one technology, service worker. What is a service worker? How many of you know? Okay. So basically, service workers are type of web workers, and web workers, you can think about web workers just as JavaScript code that is running on a different thread. Which means normally when we have a browser, we are running everything on one thread, on one CPU thread. But with web workers, we can extend it and we can run some pieces of code in a different thread. And what is very important for service workers, they can intercept navigation and resource requests, which means that if we are sending requests to the server, it works like a proxy for this request or some kind of middleware. So we can do something with this request and then send it to the server. And what is also important that it's working on a different thread. So if we will close the main thread where we have our web application, the second thread where we have a service worker can still work. So it can still work even when we close our application. And this part is very important and it's crucial to remember for the next slides, because this is the part that allows us to achieve all these magic things. So normally we can think about service workers like this. So here is a web worker, here is our website. Web worker is not aware of our website at all. He doesn't have access to DOM and etc. The only thing that it's aware is the post message, which is a function that we can contact with a web worker, and web worker can also post message to our website. And also in service workers, it's also aware of some events that our website can send, for example, a fetch event to intercept requests. And as I said before, even when we close our web application, our service worker can still work. The registration is very, very easy. We are just using feature detection to check if service worker is supported in the browser. If it is, we are just using a navigator API to register it, and we are specifying just a single JavaScript file, because service worker is nothing more than a JavaScript file that we delegate to work on a different thread. And then we can do some console logs, etc. Handle some fails. So the first, probably most common thing that service workers can do, and probably the most buzzy thing that they can do, is that they can allow us to cache stuff, and they can allow us to use this cached stuff while we are offline. So if we visit a website once, we don't need a stable connectivity. We don't even need connectivity to see it again. And this is awesome. And how it works. Let's imagine this situation, that we have our web application. This application wants some users' data from our server, so it's communicating with API. We are sending a request for this. Server is available, everything is fine, so we're getting the response with users' data. Beautiful. But what happens if the server is unavailable, if we are offline, or if anything else occurs? Then we are just having error. And we basically can't do anything. We can handle it gracefully on the front end, but basically it's a fail. So with service workers, we are telling sending this request. This request is proxied by service worker, which is again sending it to the server. In response, the service worker is getting an error, but our application is still not aware of it, because only service worker received the response from the server. And what service worker can do? Service worker can say, hey, I can fetch it from the server, I don't know why, but I can check it if I have it in a cache. So we are checking if I have it in a cache, this user's response. If we have, then we can serve it to from the cache. And our web application is basically not aware of the fact that we were offline or our backend was unavailable or something like this. So it's kind of fallback for being offline. So I think it's amazing. And the thing that you have seen is called a network first caching strategy, which means if we have a web page, then we are making a request. The request first is checking the network. If network is unavailable, then we are taking this from the cache. And it's basically suitable for most of use cases, but there are also use cases where we don't want to reach network totally, because once we have something in cache, we're assuming that it wouldn't change in the future. So there is a cache first strategy, which is doing the opposite. So first we are checking if we have some resource in a cache. We're not touching our server at all. So the resource is immediately available to the user always. And if it's not in a cache, then we are checking the network, downloading it, putting it in a cache. So in the next time, it will be served from the cache. Of course, there are a lot more strategies like network only, cache only, style revalidate. You can read about them on Google Developers Network, but basically what I wanted to, please, if you want to read more about these caching strategies, just make a photo of this and Google Offline Cookbook. You can find a lot of patterns there. Okay. So all these strategies are there because we don't want to treat all the requests and all the resources in the same way. So for example, for images, maybe we want the cache first strategy. For some JSON data from the server, we want the network first strategy, etc. And so our service worker is deciding on which circumstances which resource should we use. So should we serve it from the network, from the cache, or whatever? So this is the basic thing. And maybe you think it's hard to achieve it, but the truth is it's not hard to achieve because we have libraries like Workbox, which simplifies development of progressive web apps a lot. For example, if you will take these photos, okay? Here is all the code needed to have a Vue.js application working offline. So we are specifying some regexes, regular expressions for some specific types of files. Here for the JavaScript files, we are specifying that it should use a network first strategy. We are putting our main route, which is index.html, in a different cache. Then we are putting images in a different cache with a cache first strategy, and we are telling Workbox that if the images are in the cache for longer time than 7 days, then we should download them again. So it's kind of lifetime of them in a cache. So it's very, very easy to make application work offline, but of course it's not everything you can do with service workers. Yeah, this was supposed to appear after I said that it's quite easy. So what else you can do with progressive web apps? And basically there are two things that you should consider, because we should consider it in user experience area and in development area. I'd say performance area. So for user experience, probably in e-commerce, the most useful thing would be one-click checkout with payment request API. Basically, it looks like this. So we have the data, shipping data, payment data, our personal data in the browser instead of some account and some server. So once we click a button which is using payment request API on any website, something like this will appear, pop-up like this will appear, and we can just choose the right shipping, the right payment, click pay, and it's done. So this one is amazing for mobile checkouts, because on mobile we usually don't want to fill all these fields, and probably we are using most of the users because of this checkout. And with payment request API, it's easy as 2 clicks. And you probably also think that it's hard to implement it. No. Basically, we need to check if it's supported. If it is, then we will use it. If not, then we will redirect to a standard checkout. And on the left side, you can see a very, very, very basic setup of payment request API, which is just taking the price and allows us to pay with card. Of course, you can use more and more and more options to configure it, but with this basic setup, it will more or less work. What else you can do? You can engage your users by sending them push notifications, the native push notifications that you see on your mobile devices and on your desktops. They look like this, and they are supported in Linux, in macOS, and in Android. Unfortunately, they are not supported in iOS yet. I have no idea when they will, but apart from iOS, they are supported in every major operating system. And with this approach, even when user leaves our website, we can re-engage them. For example, we can tell them about the promotions, or we can tell them about the status of their orders, etc. And it's also very easy to implement it. We need two things. The first thing is, of course, the notification API, which displays the notification. And the second, probably more interesting part, is the push API. It allows us to listen for the push event in our service worker. Service workers, as I said, they are working even when web app is closed. So we are listening for this push event in service worker with push API. Once it comes, then it displays the notification to the user immediately. It doesn't matter if the user is on the website or not. With real time, we can reach the users just by sending, just by using a push API. That is handled in our service worker. But before doing it, we need to ask users for permission to display this notification, the permission that you probably see in a lot of websites. And important thing about this permission is that you can ask about it only once if user declines. So if user says, no, I don't want to opt in for notification, there's basically no way to ask them again. So we need to be careful with asking it. Probably the worst thing that you can do is ask about it immediately without any context at the beginning when users are visiting the website, because they are closing all this cookie information, newsletter information, probably some ad pop-up, and they will also disline to this permission. My advice is to ask it on a context so users will know why it's useful and why it's beneficial for them to subscribe. So this is only a top of the iceberg of what we can do with progressive web apps, because it's much more. For example, normally when we are making this request, if you will take a look at, I don't want to search, but on the previous slides we've seen that if we are sending a request and the network is not available, then we are getting an error. But with background synchronization, instead of doing this, what happens normally if we don't have internet connection, our request will behave like this. So it will wait until we have a stable connectivity, and then it will be passed to the server. So you can imagine like you have Facebook application and you're offline, but you're clicking like on some post. So if you're offline normally, under the hood, on the background, error will happen and the image will not be liked. But what is actually happening on Twitter and on Facebook, that you're clicking on this like icon, the request is queued, and it's waiting until there is a stable connectivity. And when the stable connectivity is reached, then the request is sent. So it's also very easy. Basically, on our application, we are registering a sync event, which is fired when the connectivity is stable. And on the service worker, we are listening to the sync event with a given tag, like here. Oh, I made a typo. Yeah, it shouldn't be camel case, but okay. But basically, the tag that we register the sync event needs to match the tag that we are listening for in our service worker. So in this case, let's say we are offline, we are placing an order in our web shop. So if user clicks place order, then we are queuing the sync event, and if we are online, it's immediately proceeded to the backend. If not, it's just waiting until we are online. And again, it's waiting in the background. We can close our web application and the request still will be sent. But what else we can do? Now I will talk a little bit about more developer experience and performance. So for example, we can prefetch resources before they are needed. So let's imagine that we are on some web shop and user is entering the main site, the home page. We can assume that the user will probably in some time click on a product page, on category page. So we can prefetch the resources for this category page and product page. So when the user clicks on the link, it doesn't need to download anything, so this page will display immediately. There will be no loading, so it's much better user experience. And another advantage of this approach is that once we have it downloaded, for example, if user is in a train, if he or she will lose internet connection, then he can or she can still see this website, can still see the product page and the category page. So it's really, really easy. We just need to use link rel prefetch and the script that we want to prefetch. So when the browser is in idle mode, then it will take care of downloading it. We can also use a workbox precache module with Webpack, for example. Another great thing, as I said, we can also use web workers on different threads. So you can imagine that in JavaScript, we normally have one thread. If we have some very intensive computing functions, they can block the main thread, which means the page is not interactive, it's blocked. So with web workers, we can delegate this task to the web worker, so it will work on completely different thread. And once this task is finished, the return of this task is sent to our application. So, for example, we can tell our web worker, hey, fetch users for me, please. So web worker is saying, hey, no problem, I'm fetching. User is still browsing the website, nothing is blocked. By the way, there is a difference between asynchronous JavaScript and multi-threaded JavaScript, because even if you think something is asynchronous, it only means that it's delayed in time. It doesn't mean that it will work simultaneously with our main thread. It just means that it will be delayed and consumed in the future. So asynchrony is not a multi-threaded approach. So with web workers, we can achieve real multi-threaded approach. So we can delegate this task to the web worker, and once it has fetched this resource, it's sent back to our web application, and voila. And basically, more or less, it can be done this way. So we are creating a new web worker with fetch.js. And in fetch.js, inside, we are just listening for the message event. There's another thing, because probably many of you heard a lot about progressive web apps as a replacement of the native apps. And all of this is done mostly by the one technology, and this technology is called Web App Manifest. How it works? We are creating a JSON file in our application where we are specifying the name of our application, the color, the splash screen, etc. And once it's there, we need to register it in our index.html, and users can install our application like from the App Store, but without using the App Store. So here on the left side, you can see a normal website with Web App Manifest. As you can see, there is a banner displaying. Once you click on this banner, the application appears on the home screen. Once you click on it on the home screen, you can see a splash screen, typical for the native web applications. And after splash screen this is dismissed, you can see that we have the same application like on the left, but without a browser UI. So user basically can't see the difference. If we combine it with offline capabilities, then we have fully working native-like application that is a web app. And as I said before, we just need to link the manifest and create it. On previous version of Chrome, like before 68, the banner was appearing automatically. Now we need to do some kind of magic to do it. We need to catch the event that normally is showing this banner and defer it in time and show it later with prompt method. But basically it's like 5 or 6 lines of JavaScript code. So this is all you need. There are also some other cool things about progressive web apps that I didn't want to mention here because there will be too much talking. But basically, for example, there's Workerize that allows you to delegate JavaScript modules to the web workers. So this is exactly the use case I mentioned before. You can delegate the JavaScript code to work on a different thread, and once the code is executed, it's returning back with the result. Also, there is service workerware, which is amazing project because it. How many of you know Express from Node.js? Okay, quite many. So basically, this is Express, but Express middlewares, but inside the service worker. So you can put a layered middlewares on our request inside the service worker. Also, there is a lot of different PWA stuff that you can find on this page, on Awesome PWA. There are resources to learn, to find the cool things. There are cookbooks, so you should definitely try it. I also tweet a lot about progressive web apps, also about Vue.js. So you can follow me if you're interested in this topic. Yeah, and that's all. Thank you. Are there any questions? Yeah?
It's a ridiculous question, but who's the guy in the photos?
This guy in the photos is Harold. He's a very famous guy from stock photos. So I'm using him a lot in my presentation, but this guy made his popularity by appearing on the stock photos because normally he looks like he has some kind of hidden pain. Like he's laughing, but his eyes telling the opposite. And so he's very popular. He even made it to a Manchester City commercial. You can find it on YouTube. You need to type something like Harold Height Pain Manchester City commercial or something like this. Yeah, so any other questions? Yeah? Excuse me? Excuse me, I will give you a microphone maybe.
How do you host these?
How do I host progressive web apps? Like normal web apps. I'm not sure if I get the question right, maybe.
Okay, no, we'll talk about it later.
Okay. Okay, so we'll talk about it later. Any other questions here? Okay, I will give you 5 seconds. Okay, so it looks like we're done. So thank you very much again. And I hope you don't think that PWA is a buzzword anymore, because as you have seen, there's a lot that can be done with it. Thanks.